Hello everyone, my name is Sadhana and this is the first of the few electricity videos I'm going to be making. This one in particular is about electricity and atoms. So I'm going to be starting off with the definition of electricity and then its relationship with atoms, the subatomic particles within the atom, and the flow of electrons from one atom to another. Finally, I'm going to be talking about the periodic table. I hope you liked this video, and please don't forget to like, comment, and subscribe, and please do share with your friends. The given definition for electricity is that electricity is the flow of electrical power or charge. This might not make sense now, but by the end of the video, I'm sure it will. To understand electricity, we need to understand what an atom is. What is an atom? An atom is the smallest unit of everything. Which means, once we take an element and start breaking it down, we will finally end up with only one atom. Now, atoms aren't the smallest, but what they are made up of is the smallest. Atoms are made up of subatomic particles. And the three subatomic particles are the protons, the neutrons, and the electrons. So the protons are positively charged, the electrons are negatively charged, and the neutrons have, no charge. So if we take helium as an element, for example, helium has 2 protons, 2 electrons, and 1 neutron. So the position of the subatomic particles in an atom would kind of look something like this. So here we have our electron cloud. Within the electron cloud we have the nucleus, which is the center of an atom. And inside the nucleus we have our protons and neutrons. So we have our 2 protons here and our 1 neutron here. I'm just going to color this in since it has no symbol. And on the outside, we have the electron, 2 electrons. So I'm just going to label it now. Here we have the electron cloud. And over here we have the nucleus. So, as you can see here, we see that size-wise, the nucleus is way smaller compared to the electron cloud. And within the nucleus, the protons and the neutrons are always bound together. And of course the electrons, which means they don't move in here, but the electrons are always freely flowing since they're on the electron cloud here. Another thing to also note is that the electrons are always orbiting the electron cloud. So now, these subatomic particles are held together by forces. What forces are they? So I'm going to use the first letter for all of them. So the protons and the neutrons, P and N, are held by a nuclear force. And the electrons and the protons are held together by electrical attractions. Now that we know this, back to the definition, I said that electricity was the flow of electrical power or charge. So a little more detailed into the definition, electricity is the flow of electrons from one atom to another. which means, let's say we have this wire, and inside the wire we have our atoms. So let's just say this is a copper wire, since copper is mostly used in wires since it's a good conductor. Copper has 29 protons and 29 electrons, but we're not going to be drawing 29 protons and electrons just to make things more simpler. So instead I'm going to be drawing 1 proton, 1 electron, and 1 neutron for copper. So inside our nucleus we have our proton and our neutron. And on the outside we have our electrons. So how electricity occurs is when the electron here bounces off from this atom here to this atom here, and this atom here to this atom here. So the reason why they use copper is because copper has 29 electrons. So there are basically 29 electrons already orbiting. So when the electron here goes to the atom here, there's already 29, and so since there's a new one, they bounce off the electron to go to the next one. And since there's 29, you don't have to wait for an electron to come and push. Since they're always moving, you can always expect for it to bounce the minute it lands on the atom. Now another thing, I said that the number of protons is always the same as the number of electrons, so they basically balance. So when we have, let's say there's another atom here, and the electron here goes to this one, and the one that's already here goes, now there's 2. So there's now 2 electrons for 1 proton, which is now they're imbalanced. So to make them balanced, that is why the electron here goes to the next atom. So you might have noticed me saying that the electrons are the ones that move from atom to atom. And you might be wondering why it's not the proton, let's say, which is the one that moves from atom to atom. And the reason why it is not the proton is because I said that the protons were bound together with the neutron in the nucleus. So they're really tight together. So if you want to take it out for it to orbit, then you're basically splitting an atom. So the term for splitting an atom is called nuclear fission, and doing that will cause a nuclear reaction, which is hazardous, which is why the protons are not the ones which orbits atom to atom. So helium, so the examples we used so far were helium and a few more, and these were all elements. So to find out how many protons, electrons, and neutrons there are in an element, you'll need to refer to something called the periodic table. So the periodic table is basically a table listed with many elements, and each element is the name is within a box. And so for example, let's say we take oxygen, for example. Now, the way they represent oxygen in the periodic table is that there's an O in the middle, there's an 8 on the top, the word oxygen on the bottom, and the background color for it is blue. So how to figure out the information about oxygen is, first of all, you would know it's oxygen because the name of the element is on the bottom. This O over here is the symbol for the element, so they just use O for oxygen. This is just a coincidental for this element. The number on the top is the atomic number, which refers to the number of protons in it. And the blue on the side will tell if an element is either solid, liquid, gas, or if it is not found in nature. So once again, the top number is the atomic number. The number down here is the name of the element. The blue is the color representation and the O is its symbol. So since it's blue, again, we know that, since it's blue, we know that oxygen is a gas.